Welcome DIKWP Sogong aboard. Your learning journey starts now. Ever felt like math has a secret history? What if we could wipe the slate clean, reset everything before the word conjecture even entered the picture? Forget solved or unsolved labels for a second. Let's peek under the hood at the very core of how these big mathematical puzzles are actually built. So, what's the new foundation? It boils down to 5-letter P. Think of them as the fundamental building blocks. D is the raw data, the stuff we start with. I is the new information, the differences that pop up. K is our current understanding, what we've got figured out so far. W is the why, the value judgments, the choices we make about what matters. And P is the process engine driving things forward. These aren't just random letters. They're connected by 25 specific pathways, showing how knowledge flows and transforms. This is the native language, the bedrock. Now, here's where it gets interesting. We have 3 layers. At the very bottom, the core layer, that's our DIKWP system. Pure, unadulterated, no preloaded assumptions. Think of it as the DNA. Above that, the alias layer. This is where we put the familiar names: Fermat's last theorem, Riemann hypothesis, Goldbach conjecture. They're useful labels, but they don't define the core object itself. Finally, the history layer. This tracks the outside world's view, the community consensus, whether something was declared, solved, or unsolved back then. The key rule: information flows one way, from the core outwards. The alias or history can never rewrite the core. No going back to change the original blueprint. Let's zoom in on those 25 paths. They're not just abstract connections, they tell stories. The most frequent ones, hitting 72 times each, are D to K, K to D, and P to K. What does this mean? D to K means the given data successfully becomes part of our current complete knowledge. K to D means our current knowledge can trace back to its original source. P to K means a process actually generates the knowledge we currently possess. And P to P? That's the engine humming along, meaning generation can continue without stopping or claiming completion. These paths reveal the hidden dynamics behind traditional problems, often compressed into formulas. They show the flow, the accountability, the how. Okay, let's tackle a big one: infinity. Traditional math often starts with an infinite set of integers. Mesh 8.1 says, hold on. We don't assume a completed infinity exists in the core. Instead, we look at stages, S, wheel, and so on. Each stage generates the next, n+1, via process P. The crucial part: there's no final infinity object. The fact that P to P allows the next step doesn't automatically mean all properties are covered now. Infinity, in this framework, isn't a foundational axiom. It's more like an alias, a description of the ongoing process, something you add after the generation happens, not before it begins. So, what's the big takeaway? This approach isn't about discarding old math, it's about rethinking its foundation. By starting fresh with DIKWP and keeping things append-only, we strip away dogma and open up new ways to think about problems, old and new. It's about clarity, traceability, and letting the structure speak for itself. Now, armed with this perspective, what questions do you have? What puzzles will you approach differently? The floor is yours.